Hello dear, so this is our example this morning, specifically on how to add vectors using the component method. So we can do this by simply resolving the force into its x and y component. Okay, so given these three forces, F1 lying on the first quadrant, then you have F2, there are no force, then you have your third quadrant, and you have your fourth quadrant. So these are your quadrants. So you will see that in the first quadrant, your x is positive, your x is plus, and your y is plus also. Okay? In the second quadrant, your x is negative and your y is positive. In the third quadrant, your x and y are both negative. Okay? And in the fourth quadrant, your x is positive and y is negative. So you have to know these signs in order for you to solve the resultant force of any given vector. Okay? So how do we resolve the component of the force? We can put it this way. So you will see this is our F1, and along this line is your F1x, and along this point is your F1y. Okay? So we can put it in a table so that it will be easy for you to solve the problem. So this is your force and the theta given and your x and the y. Okay? So here your F sub 1 is simply equal to 600. Okay? And the theta is 30 degrees. So you will see here that the theta here is lying along x, and when it lies along x, that means your x is cosine. So simply, to find for the component of F1x, we apply cosine of 30 degrees is simply equal to F1x divided by F1. So to find for F1x, you cross multiply, you will get F1 cosine of 30. So your F1x is simply equal to F1 is 600 times cosine of 30. And of course, your F1x is simply equal to 500 cosine of 30 times 600, and we get 519.6. So we can write it as 520. Okay? So 520 newtons. And you will see that this is positive. Okay? And you getting the component of F1y. So your sine of 30 degrees is simply equal to F1y divided by F1. So your F1y is simply equal to F1 sine of 30 degrees. So your F sub 1y is simply equal to F1 is 600 times sine of 30. Therefore, this is 300 newtons. And again, your F1y is positive. Okay? So getting the value of our F2. So you will see this is our F2, and your F2, so this part here is our F2y, and around here this is your F2x. Okay? Again, your F sub 2 is simply equal to 500 newtons. Okay? And the theta is 60 degrees. So finding for your F2, again applying, so cosine of 60 degrees is simply equal to F2x divided by F2. Okay, so your F2x therefore is F2, which is 500 times cosine of 60. Okay, therefore your F2x is simply equal to 250 newtons, and this is positive. Okay, now finding for your sine of 60 is simply equal to your F2y divided by F2. Okay, so F2y is F2 sine of 60 degrees. So your F2y is simply equal to sine of 60 times 500. Okay, 433. Okay, and you will see that this is a negative. Okay, because along this portion here, your y is minus. So F2y is negative 433 newtons. Okay, now next is to find the component of your F3. And F3 is 450 newtons. And you will see that the sides of the triangle are given. So going back, you will see that this is 3, this is 4, and this is 5. So finding for this angle theta, okay, you will see that your sine theta is simply equal to 3 divided by 5. And therefore, your theta is simply equal to shift sine of 3 over 5, you will get 36.86 or approximately 37 degrees. So this angle is 37 and this angle here is 53. So you can opt to choose this theta here or this theta here. Okay? So using this theta here, this is the one that we will use, which is equal to 37 degrees. Then we can say theta is 37. Okay? So therefore, our F3x, this is your F3x. Okay? And this part here is your F3y. So you will see that F3x, okay, you will see that for this problem, our sine of 37 is simply equal to F3x divided by F3. Okay? So F3x is opposite. Therefore, your F3x is simply equal to F3 sine of 37 degrees. So your F3x now is simply equal to F3 450 times sine of 37 degrees. So F3x is simply equal to 450 times sine of 37. So we get 270.82 newtons. And you will see that F3 is negative. So we put the negative sign here. Okay? So in like manner, we get also F3y. And F3y is simply F3 cosine of 37 degrees. Okay? F3 cosine of 37. So your F3y is simply equal to F3 450 times cosine of 37. So 359.38 or 359.4. 359.4 newtons. So you will see here that F3y is also negative. Okay? So now we have finished all getting the components of each force. Now we will get summation of forces. So here we need to find the forces, summation of forces along x, and we need to find the summation of forces along y. Okay, so getting it, so you will see that F1x is positive, so 520 plus 250 minus 270.82. Okay, so you will see that our summation of forces along x is 499.18 newtons, and this is positive. And summation of forces along y, F1y is 300, okay, minus 433 minus 359.4, okay? So you will get 492. So the answer here is negative 492.4 44. Okay? Negative 492.4 newtons. So using our Pythagorean theorem, our FR is simply the square root of summation of f of x squared plus summation of f of y squared. So your FR is simply equal to 499.18 squared plus the negative 492.4 squared square root. Okay, therefore our FR is simply equal to so your answer is 701.2, okay, newtons. Okay, so this is our resultant of the force. So getting the angle, our tangent of theta is simply equal to summation of f of y divided by summation of f of x. Okay? Therefore, our theta is simply equal to shift tan f of y negative 492.4 divided by positive 499.18. Okay, therefore our theta is simply equal to negative 492.4 so answer is 44.6. Okay, negative 44.6 degrees. Okay, so this is our answer for this problem. Okay, there?